Okay, example number 3. For this problem, when you read this problem, you can easily understand it is damped free vibration motion. Okay, so like basically the differential equation would be this one: m u double prime plus gamma u prime plus ku equal to 0. Okay, so what about m is mass? Like, in the problem, there's a mass weighing 16 pound, right? So we have to this is mass weighing, so we have to find mass. Okay, so basically mass weighing is mg. So 16 pound means the mass m times gravity. Gravity in terms of pound is 32 feet per second. Basically, okay. In this problem, even in the spring is stretched by 3 inch, we're gonna use feet instead of inch, okay? Which is 1/4 feet, right? So your gravity will be written by 32 feet per second, okay? So my mass m must be equal to 16 over 32, which is 1/2 pound, okay? So we're gonna plug in this one later, okay? And the second one, by that mass, your spring is stretching out 3 inch, right? So we can, with this equation, we can find constant K, spring constant K, by the Hooke's law, okay? There we go. Which is mg equal to kx, right? mg is 16 and k and stretching length is 1/4 feet. So we can find the spring constant k, which is 64. Is okay? Now we are ready. And it's the damping coefficient is given, which is 2 pound second per feet, right? Then we can update everything. Update differential equation with all the information, okay? M is 1/2 u double prime, damping coefficient, which is given by 2 pound, 2 u prime, and we found the spin coefficient, which is 64. This is my differential equation. As you can see, it is homogeneous second order linear differential equation with constant coefficient, right? And now we're ready. Now, we can use characteristic equation, which is 1/2 r squared plus 2r plus 64 equal to 0, okay? And let me multiply 2 on both sides. Then this will be just like r squared plus 4r plus 128 equals to 0, which is quadratic equation, okay? And let me use the quadratic formula to find r. Your r is equal to minus b plus and minus square root of b squared minus 4 times 1 times 128 over 2a, okay? And let me simplify this, okay? It is equal to -4 plus and minus and square root of 16 minus 512 over 2, which is equal to -4 plus and minus square root of minus 496 over 2 then we can easily figure that out. We can take some common factor out. For square root of 31 I, because that is negative value, right? So that is -2 plus and minus 2 square root of 31I, okay? Which is complex form, okay? We know the solution form of this one, right? It must be exponential function and cosine and sine form, okay? So therefore, the general solution, ut is equal to 8 times e to the minus 2t times cosine of 2 square root of 31t, and plus another constant b, coefficient b times e to the minus 2t times sine of 2 square root 31t 4. Is that okay? So now, well, okay, let me come back to the problem, okay? Like, actually the initial condition is given, okay? There we go. Look at the problem. So, okay, look at second line. I'm talking about this part, okay? If the mass is set in motion from its equilibrium position, right? That means u0 is equal to 0, right? And like downward velocity is 3 inches per second. That means u prime 0 equal to 1/4 feet. Does it make sense? So we're going to use these two initial conditions for my general solution, okay, to find A and B, okay? So here we go. Since u0 equals 0, then u0 means the sine part equals 0, that it is 8 times e to the minus 2t must be equal to 0, right? In other words, ma A equals 0, because exponential function never equals 0, okay? And what about the second part? We need then we can update my ut, right, is equal to b times e to the minus 2t times sine of 2 square root of 31t, right? And then we need u prime to use the a second initial condition, right? So what is that? It is definitely product rule, right? E to the minus 2t and sine function, okay? Then by the product rule, let me write b in front, and e to the minus 2t prime, which is minus 2 e to the minus 2t times second function, which is sine function, 231t, and plus, because that is the product rule, okay? And first function times second function prime, which is cosine function, and don't forget the chain rule. That's it, right? So let me simplify a little bit, okay? But well, it doesn't matter, okay? We can find the answer directly. Since u prime 0 equal to what was it? Was 1/3 or 1/4? 1/4, right? Plug in 0, then definitely your sine term will be equal to 0, okay? Then you're gonna have b times e to the minus 2t times cosine 0 equal to 1. That's why we don't have to worry about that part. That is equal to 1/4. Oh, sorry. E to the 0 equal to 1 as well, right? Then we can rewrite this one as like this way. Let me rewrite everything, okay? U prime 0 equal to b times e to the 0 times cosine 0 times 2 square root of 31 must be 1/4, which means b times 2 square root of like 31 equal to 1/4. Then my b is 1/8 square root of like 31. Okay, and you can do the rationalized denominator, but like I don't care about that. Okay, so let me update my solution. U t is equal to what was it? There we go. 1/8 31 times e to the minus 2t with the sine function, right? Sine of 2 square root of 31 t. That's it. This is my solution curve. Okay. Then look at that. Like since it is the like the singular sine function, we can talk about the frequency and period. Okay. But this one, as you can see, like the power of like exponential function part is negative, which means whenever t is increasing, that converts to the 0. Then this oscillation is getting smaller and smaller and smaller, right? So like, we cannot find like exact frequency, but like we can find like kind of frequency which is named quasi frequency, right? Here we go. The quasi frequency is noted by mu, that is 2 square root 31. And what about the quasi period? Is we noted by TD, that is equal to 2 pi over mu, right? Which is 2 pi over 2 square root 31, which is pi over square root of 31. Okay? It's okay. It's almost here. So like we need to do one more thing. Like let me come back to the problem, okay? Not only frequency and like period, and the problem asks to find the time tau, such that like the absolute value of u is less than 0.01, right? There we go. To determine the time tau such that ut less than 0.01. Oh, it is inch, right? Then it must be changed into the feet. A 0.01 inch is 1/1200 feet. Okay, so let me come back to the problem and let me mark that part. Okay, this inch part is equal to 1/1200 feet. Okay, that's why we're going to use like 1/1200 instead. Okay. Okay, so how can you solve this problem? My ut was found before. This one, ut was, there we go. The absolute value of 1/8 square root of like 31 e to the minus 2t times sine of 2/31t is less than 1/1200, right? So well, like this one is not easy to find this one exactly, okay? But think about it. We have like sine function. We know like, the range of sine, right? Which is from -1 to 1, right? So we can do like, we can set up like this kind of inequality, okay? Absolute value of 1/, okay, let me write like one here. This one is always less than like positive, which is 1/831 e to the minus t. Does it make sense? Like this is much easier to find at this interval, right? Okay, the reason is that your sign is between -1 to 1. Okay, let me multiply 8 square root 31 on both sides. And this can be by e to the minus 2t is less than 831 over 1200. Is it okay? Let me simplify. Divide by 8 top and bottom. 1 50, right? Okay, so let me take the reciprocal of this one. Okay, e to the 2t must be bigger than 150 over. Okay, then since like both of them positive number, then we can take the just log on both sides. Okay, and this will be ln e to the 2t is 2t, right? It's bigger than ln of 150 over the square root of like 31. Okay, when you use calculator for this one, it's approximately 3.29. Okay, so your t must be bigger than like 1.6. Oh, where is it? We also have something more. There we go. I can make 1.645 seconds. Okay, so your tau, which is satisfied this equation, must be like bigger than 1.645 seconds. Okay, thank you. Sorry for like any interruption.